refresher, bro. What? Lower the mic a little bit. Alright, so today what we're going to do is we're actually just going to be reviewing most of the stuff that we have already talked about so far. We're just going to add some new stuff on the back. So, as a refresher, if we wanted to simplify, looking at number 1 here, if we want to simplify the following, we are going to break down what is inside the number. We're going to break down what's inside with the variables as well. So for 60, I'm going to think of a perfect square that goes into 60, and I can count, I can think all I want, but the only one that I found was 4. 4 times what is going to be 60? 15. So that means I'm going to take one of my, since 4 is a perfect square, I'm going to take the group of 2's that make up that 4 and bring it to the outside, leave my 15 on the inside, and I'm going to do the little trick with mixed numbers for my exponents. So I have x to the 8 divided by 2 is going to be 4. So I know I'm going to bring all 4 of my x's out to the front, and then I'm going to be left with, I have y 15 over 2, which is 7 and 1/2. So I'm going to have y to the 7 on the outside and just 1 y left on the inside. Alright, so once I have finished that, I am going to go on to number 2, and we are subtracting radicals here. So this was R5 what we did, so I am going to break these down with thinking about which perfect square goes into each of them, and then my goal is to have the radicand be the exact same number underneath, so that way I can combine them. So the square root of 40 is going to break down into 4 times 10, take out the 2 that makes up this 4, so I'm going to have 2 root 10, and my goal here is I want this second one, the 3 times the square root of 90, I want the inside to be a 10, because when I broke down 40 I have 10 left over on the inside of my radical, so I want to do the same thing for the other one. That's usually the best place to start. Otherwise just break them down. If you don't like to think about it that way, you can just break them down normally, because you're going to end up with the same thing. So if I break down 90, I'm going to have 9 times 10. Now 9 is my perfect square, which means we're going to bring a 3 to the outside. Now if we notice, we already have a negative 3 on the outside, so when I multiply, what I'm going to do is negative 3 times the 3 that I bring from my 9, leaving me with a negative 9 root 10. So finally I'm going to subtract them, 2 minus 9, and keep my root 10's, so I'll have a negative 7 root 10. Alright, so that is kind of a refresher, as well as all of this stuff down here. For number 3, I'm going to be dealing with cube root. So I'm going to think of what cube root goes into 40, a perfect cube, sorry. I'm going to have 8 and 5. 8 is my perfect cube, which means I'm going to bring a 2 to the outside. And on the inside, I have x to the 5 left over for my variables. So I'm going to divide that 5 by 3, and I get 1 and 2/3. So I know I'm going to take 1 x to the outside, and 2 of them are going to remain on the inside with that 5. Let's do the same thing. I have y to the 12 divided by 3 is going to get me 4. So I know I have 4 y's that are going to be on the outside. I'm actually just going to erase this stuff on the outside because I'm running out of space here. So I have, there's an eraser. I have 2, what did I say, x, y, 4. And then my last thing, I have z2, which we know that because that number is going to be less than 3, I'm not going to pull any of the z's out front. I'm just going to leave both the 2's on the inside, and that is what I have as my final answer. Again, this is all reviews, all stuff that we have seen before. So for number 4, break down 52. 52 is going to break down into 4 times 13. Nothing else really works. 4 is my perfect square, which means I'm going to bring a 2 to the outside, leave a 13 on the inside. A 12 over 2, I have 6 a's, so I'm going to bring out to the front, 6 groups of 2, and I have nothing left on the inside. Number 5, again, we're still going to break this down. If I were to break 45, I'm going to have 9 times 5. 9 is my perfect square, so that means I'm going to bring a 3 out to the front. So out front now I have 7 times 3, and whatever's left of my radical. So I have 21 root 5. And as I'm going to the second one, my goal is I end up with a 5 on the inside. So 25 times 5 is going to get me 125. 25 is the perfect square. One of those 5's comes to the outside. Negative 3 is going to multiply by one of those 5s, and I will have a negative 15, leave one of the 5s on the inside. If you remember, this might be a little confusing because you said, oh, I pulled one of the 5s out because I have a perfect square here, but really if I thought about it this way, I'd break this down into 5 times 5, so I'd have 3 5s altogether. So that's why I'm only bringing one of them out, is because I'm looking for every pair. For each pair, you take one out to represent it. Now I'm just going to subtract 21 minus 15. Have my answer, 6 root 5. Alright, so that is all stuff that you've seen before. That is all basically review. What is new is going to be the stuff on the back. Now, we are going to add a little bit of new stuff in here. So we're going to deal with division. So what we can think about if we wanted to set up a rule, just like how we had exponents, if I had 1/3 and I wrote it to the power of 4, what I thought about is I distributed that exponent across to both of these. The same rule is going to apply for square roots. What I can do is I can take the square root of, if we had a over b, let me make the square root sign a little bit bigger. What I can say is it's the same thing as the square root of a divided by the square root of b. So I really can distribute that square root sign across to both of these. So if we were to think about that for number 6, I'm going to take the square root of 7x squared, and I'm going to take the square root of 4. So when I go to solve the first one, 7 can't be broken down any further. There's no perfect squares that go into it. However, x squared, if I divide it by 2, I'd just have 1x on the outside, and I'd be left with a 7 on the inside. And then I would evaluate, is there a square root of 4? Yes, there is. It's 2, and I'd have my answer. So the only difference between this and the other stuff is you have to square root both parts of the fraction, and you can decide to rewrite it like I have down here, or if you can jump that step and kind of do it mentally, you don't have to do that step at all where you rewrite it. So if I go to number 7, I'm going to look at, can I take the square root of 18 b squared c4 and the square root of 9. So as I'm moving forward to break down 18, the square root of 18 is going to break down into 9 and 2. 9 is my perfect square, leaving 2 by itself on the inside. So I know at the bare minimum for the top, this is what it's going to look like. I have a 3 on the outside, 2 on the inside. When I take b12 divided by 3 divided by 2, I'm going to have 6. So I know I'm going to bring 6 b's to the outside. And then c4, I'll have 2 c's left with a 2 on the inside. So the only thing that I'm leaving on the inside is the 2 from the 18. Everything else is coming to the outside. And then I'm going to see, can I take the square root of 9? Yes, you can. The square root of 9 is just going to be 3. And so now from here I would look and see, can I simplify this any further? So your last step really is just check, double check, triple check, make sure everything on the outside is simplified, and you're good to go. So I noticed that I have a 3 on both of these. So those are both going to cancel out, leaving me with nothing in my denominator, just a 1. And my final problem is just going to be, or my final simplified radical is just going to be everything that I have without the 3's. For number 8, I'm going to be following the same process. I'm going to be writing it as the cube root of 8x, 10 over the cube root of 27. Now if I'm doing this top part right here, the cube root of 8 is a perfect cube, so I know that there's going to be a 2 on the outside, and then when I go to do the x, I'm going to take 10, divide it by 3, and I'm left with 3 1/3, meaning I'm going to take 3 x's to the outside, leave, I'm going to write the little 3 here, leave 1 x on the inside, divide it by what is the cube root of 27, that one is perfect, cube, it is 3. So really you're taking them piece by piece, breaking it down and coming up with your answer. Now you can write your answer like I have right here where it's everything is all over 3. You could also write it as 2x cubed over 3 times the cube root of x. I mean, these are just alternate ways that you can write it. It's still the same thing if you just want to keep everything on the outside, but it's the same answer logically. Alright, so that is everything from me. I hope you all have a wonderful day. And if you have any questions, please feel free to ask.